Hassler here. I'm going to run through the lesson that we did together in class in our groups for 5-4. It says Janelle reheats a cup of coffee in the microwave. The temperature of the coffee in her mug, measured in degrees Fahrenheit, from when she first put it in the microwave to when she finished drinking her cup 10 minutes later, is shown in the graph below. So one says, what is the temperature of the coffee when she first put it in the microwave? All right, so this scenario says that this graph shows when she first put it in the microwave to her finished drinking it 10 minutes later. So the temperature of coffee when she first put it in the microwave. I'm looking for when the time, so I'll say T for time, is 0. The temperature would be right here on that y-axis. Looks like I'm going up by 20s, which means halfway between 60 and 80 is 70. So I would say that the temp was 70, and I'll label it degrees Fahrenheit. 2 says, describe how the temperature of the coffee, again, temperature is on that y-axis here. Describe how the temperature of the coffee changed during this 10-minute interval. All right, so I start at 70 degrees. I'm going to put it in the microwave. So it looks to me like I'm increasing. My temperature is getting hotter. I bet I take it out of the microwave here because now, after I take it out of the microwave, it looks like my temperature is going to decrease until I drink it, finish it off. Okay, so it looks to me like the temperature increased. I'm trying to spell temp here. Temp increased. And then it decreased. Now I can get a little bit more specific here. It looks to me like I'm increasing at a constant rate because this is a straight line. So I'm really increasing, and I'm going to say at a constant rate. Or at a steady rate. I'm going to say that instead. And then I decrease, but this decrease is like not consistent, right? Decrease. So looks like I decreased quickly, then gradually. Like it looks like a pretty steep decrease, and then it kind of levels off. 3 says, how long did she microwave the coffee, and how do you know? So I mentioned that before. It looks like I'm microwaving my coffee, and then at this point up here, I must have taken it out because I'm no longer heating up the coffee. Once the coffee's done heating up, the temperature is going to start to decrease to meet the air temperature of the room. And so it looks to me like it's this point here on the x-axis. And so again, I'm going by 2s. So the halfway point would be 1, so probably 1.5 minutes. And how do you know? The temp stopped increasing. And what was the temperature of the coffee when she took it out? So at this highest point right here, looks like 170 degrees Fahrenheit. All right. So one thing that we did is we're going to go back as a whole group, and we started writing some notes in. Looks like my coffee was in the microwave starting at 0 minutes and ending at 1.5 minutes. And I said it's because the temp stopped increasing. So I really could say that the temperature was increasing from 0, I'm going to say T for temp, to 1.5 minutes. The temperature of my coffee was increasing. And so this is one of the ideas that we're going to talk about, is when I'm increasing versus when something is decreasing, and over what period did that happen. So my temperature was increasing over the period of 0 to 1.5 minutes. I say this because we're going to be asked question 4. And so question 4 says, how long did it take Janelle to drink her coffee? And so again, can't drink it while it's in the microwave. So right here, I take it out of the microwave, or Janelle does, and then it takes her the rest of the time to finish drinking her coffee. And so that takes me from 1.5 minutes to 10 minutes. And so if I subtract those, I would get it took her 8.5 minutes. How do you know? Well, the temp was decreasing. So it's out of the microwave, okay? It's not increasing in temp. And again, we can say that temp is decreasing, and it's decreasing over the time period 1.5 to 10. So we're going to talk about these intervals in which we're increasing or these intervals in which we're decreasing. And we're going to write those intervals over that period of time, which are values on the x-axis. 5 says, what was the temperature of our coffee at 6 minutes? And so 6 is that input. I'm going to go back to my grid here. At 6 minutes, which would be right here, I got to look up at my grid. And the y value that matches that is 130. At which time t was the temperature of our coffee 145 degrees. So now I know the temperature, 145, which it's going to be tough to get in here, but let's see. 145 is right in here. And it looks like I crossed twice, right? I crossed this graph here and I crossed this graph here. And so if I look down at my graph, it looks like that's happening at about 1.25 minutes. And if I look down here, maybe 4 minutes. Okay. 7 says, what is an appropriate domain and range for this function? So we've talked about domain and range before. In fact, I'm going to get rid of some of this stuff here. It's starting to look super messy, right? So domain is dealing with the all the x values that get used, and range is dealing with all the y values. So all the x values that get used, I use an x value of 0 all the way out to an x value of 10. So an appropriate domain would be 0, less than or equal to, I'm going to, again, use t for time, or x would be fine, less than or equal to 10. And range are all the y values that get used. And so let me, I'll change colors here. Looks like the lowest y value that get used is 70. That was the temp of the coffee before she puts it in the microwave. And the highest temperature is 170. So every y value between 70 and 170 gets used. And so my appropriate range would be that. It would be 70, less than or equal to y, less than or equal to 170. And 8 says, does the coffee cool at the same rate as it heats up? And this is that idea that I was mentioning earlier. In problem 2, it looks like I'm increasing at a steady rate, but then my temperature is decreasing at more of that curve. It's decreasing quickly and then gradually. And so the answer is no. They're not increasing and decreasing at the same, right? So it is no. Oops, got it right though. No. It's increasing at a steady rate. In other words, this is a line, so we're going to say linear for that increase, but it's decreasing not at a steady rate. In other words, the decrease is not a straight line. So we can say not linear. Okay. All right, and so your job is to go ahead and try your best at the 5.4 Check Your Understanding. I would encourage you to watch the 5.4 notes page on the vocabulary and the example before doing the Check Your Understanding, and then, of course, asking me questions that you have.